move on to another very interesting topic, which is about nested queries, right? So nested queries are very convenient to write in a lot of scenarios. We'll see some. So how does a nested query look like? Well, when you have a nested query, then you can think about an outer block and an inner block. So whenever we write a normal SQL query which is not nested, then you will have select, like the way we have here. Select some columns you want in the result. Then from here you'll have the source table or tables, and then there could be a where clause, and then could be having, order by, all those things. But everything happens like single query, all right? But in case of nested query, what can happen is, after this where, when you're expecting a predicate, that predicate could be replaced by another query, right? So that is what you're looking at on the slide. All right, we can think of two blocks. Each block means a select query. That's the outer one. And after where, right, like these three dots that you have here, I can replace those with this term called predicate. For this predicate, what you have, this predicate involves another SQL query. Okay, that's the nested. That's an example of nested query. Outer block as well as inner block. Sometimes this inner query is also called the nested query itself. Outer query or the nested query. Okay, so let's look at an example of a nested SQL query. Fine, let's see what are we trying to do here. You know, if you only pay attention to this part, the outer part, right? We are interested in selecting the supplier name from supplier table where supplier number is equal to some value, right? So in a simple query, you'll have a value over here, and this whole thing will be a predicate, right? But what are we doing here? Interestingly, we don't have any specific value here, but that value that we want in a simple query would be coming from this inner query or the nested query, right? So let's see what this nested query is doing. And if you guys are new to SQL, right, if you are learning SQL for the first time, probably nested query might sound a little difficult for you. If that's the case, then I'll say that in simple queries like this, what you should do, first focus on the inner query, right? So this box I would say. And that is how actually, the DBMS also, or the query parser also, you may say, resolves it, right? It goes from the innermost query to the outer one. So what do we have in the inner query? Let's resolve that first. We want to select supplier number from purchase order. Purchase order is a different table, right? So in this case, if you look at it, then there are two tables involved. In the outer query, the table involved is supplier table, and inside the inner query, the table which will mark as number 2 is the purchase order, right? So what is in our SQL query doing here? We are selecting supplier number from our purchase order table where PONR, what is PONR? Purchase order number, okay, where purchase order number is 1560. So in the inner select query, we want to find out the name of the supplier who has put this supply order with who has put this purchase order with purchase order number as 1560. All right, and in this purchase order table, this purchase order number is the primary key. That's what I remember. I didn't look at that table today, but pretty sure that, in case of purchase order table, PONR is its primary key. Good. So for this purchase order, you will be able to find out the corresponding supplier number. Then what do we have here? Once you find the supplier number from this inner query, that will be a scalar result. Right? You understand scalar, non-scalar? Scalar means a single value. Okay, and non-scalar where we can have multiple values, right? So here we will get one result. The supplier number corresponding to this purchase order with the purchase order number 1560. Good. Once you have this value, then this query gets a lot easier, right? Why? Because this outer query is on a supplier table, so we don't need to join here. But let's see what are we doing in this nested query. First, look at the inner query first. Make sure that you follow what the inner query is doing. The inner query is finding out the available quantity for this product number, which is 0178. Let's assume that value is n, and once you compute this value n, then on that value you can evaluate the outer query. Okay, fine. So in all these queries that we have written till now, the result of the inner query was a scalar value, right? It is possible that the inner query may also return in a multistat, okay, with multiple values rather, non-scalar value. So let's look at the next query. So next query is also one that is nested, but there is a difference between this query and the previous queries that we saw, right? So how? Let's look at it. Well, first of all, we will have to understand what this query is trying to do. We are interested in the name of the supplier, and the supplier name is coming from supplier table, okay? And then there is this condition, right? The supplier number should be equal to what? For that, we need to understand the inner query or the nested query. So this nested query that we have and the nested queries that we have seen, or the inner queries that we saw, they can run independently, right? If you take that query out and try to run, then all the queries that we have seen are going to run, all right? Like this one. If I take only this thing out and run, then it will provide me some answers, right? Same was the case with the previous one also. Only this query, if you take it out and run, this will give you some result. Now, why am I discussing this thing? Because something related with this we will see very soon, okay? All the nested queries that we have seen till now, the inner query will run independently if I take that out and try to run. Good? So what should we do? Let's try to understand this inner query, which I may mark as A, and then we will worry about B. Select supplier number from supplies. Now this is a different table. So here in this query, outer query involves supplier table, whereas the inner query involves supplies table. All right, and from supplies table, we know that we are interested in the product number with value 0178. Okay, right? So the previous queries that you saw, the value that the inner query was returning was scalar value. Okay, available quantity, it's a scalar value. And what was the previous query? I forgot the previous one, but yeah, in all the previous cases, the inner query was returning a scalar value. But here, the inner query is returning what? A list, as he pointed out. We are getting the supplier numbers of those suppliers who are supplying the product number 0178, right? It's possible that there are multiple suppliers who are returning, who have supplied the product with the product number 0178. Now we want their name. Okay, so one thing that you need to keep in mind is, for this kind of scenario, what we will have to use, we would have to use in as the condition, right? So for that you should understand how this in works. All right, so how will this outer query connect with the result of the inner query that is resulting a list? From the supplier table, you will only return those supplier names whose supplier number happens to be 1 in this list. All right, yeah, so the only interesting thing that we have in this query versus the other one is, first the result, where is my pen, the result here, and the use of the keyword in. We are not using equal kind of a thing, right, or greater than that kind of a thing. Yeah, Good. So, till this point we saw the nested queries involving two levels. Okay, it is possible that we can go further down. So, the third query that you are looking at involves three levels. Now, think about it and tell me, what are we trying to find? Okay, supplier, supplies, product. There are three tables involved, right? What are we doing here? Well, we do have the result, but yeah, can you guess what kind of query we have written? Or can we write the same query in a simple way? Select supplier name from suppliers where supplier number N, select supplier number from suppliers where product number N, right? Select product number from product where product type is equal to rows. Right? For this kind of question, what you need to think about is the table structure, right? What are the tables involved here? There are three tables involved: a supplier table, supplies table, and the product table, right? And why do we need all these three tables here? Because they are involved in a relationship. Okay, so this table that you have in the middle, supplies, is the table that implements many-to-many relationship between the supplier table and the product table. Okay, so now does it have? Do we know what we are doing? This query is slightly difficult to write and could be a question worth 5 points for your final exam. Write this, I won't say write this way, right? I'll give you the simple part, or maybe I'll give you just the English statement of a query, or could be 10-point question, okay? Yeah, so in the question I will provide you what I'm asking you right now, like what is this query doing, okay? And then I'll say, okay, in part A, write a simple query, right? In the part B, I'll say rewrite the query using nested queries. Yes?
Is this query getting the names of suppliers who supply rows 1?
Who supplies what?
The rows type 1.
Yeah, that's the case, right? Yeah, very good, right? So again, for this query also, which may look challenging, I'm not sure what's the case here. From where should we start? Bottom up, right? Let's resolve the innermost query, right? So he would agree with me. So what is this innermost query doing here? From that product, okay, we want to find out product numbers. We want to find out all those those product numbers whose type is rows. Okay, so you will have a list or a scalar value here. What kind of value we are getting from the innermost query, this query here in the box? List again, right? So here it will be the list of all those product numbers whose type is rows. Okay, and what is the outer query doing here? Select supplier number from supplies where product number is one of these product numbers, right? So what values do we have here? Again a list, but this list is the list of supplier numbers, right, who are supplying this wine of type rows. Good. So here it was a list, here it is a list, and in the outermost query that we have, we want the supplier name from supplies, right? So we will look at one tuple at a time, and then we will check whether the supplier number of this particular tuple happens to be one that we have obtained in that query. Is now making sense, right? We want the name of the supplier who is supplying the product of the type rows, right? Now the next question, can we write this query in a simple way? Answer is yes, right? There are three tables. We know the kind of relationship that we have. We know the primary key and foreign key mapping. We would write this with join, right? There are three tables. You would write two joins, and a condition for this product type. Okay. All right. So let's see what we have next. Here again, this is interesting. Okay. So let me throw it to you people. What are we doing here? Let's start with the tables. What are the different tables here? The product table, supplies table, and supplies again. Why do we have supplies at 2 times? The innermost query. Select product number from supplies where supplier number is 84. Okay, so this is going to be a list again. Okay, because this guy supply with supplier number 84 might be supplying multiple products, so you get a list here. And how about this guy? How about this one? Interesting thing is that these 2 queries that you have, let me put those inside the box. This query and this query are kind of similar, right? Don't you see that? Supplies, right? Product number, supplies, where supplier number is 32 and supplier number is 84. So these 2 queries can run in parallel. You see that? Same kind of thing we are doing. The only difference is that the supplier number is different in this case. Okay, fine. So you'll have one list here, you'll have one list here. Now what is happening in the outermost query? We want to find out the product name from the product table where product number is in this list and also in this list, right? So what he's telling is in fact correct. All right, yeah. So when you have the outer, when you're selecting the product name, right, when you're looking at each tuple in the product table, you would check whether for that product tuple is the product number occurring in this list as well as in the other list, right? Why should we be concerned about as well as? Because look at this and good, right? Now the second question is, can we write this query in a different way? I believe you can, right? All right, good. So here we need to understand the nested queries. Now we have even interesting case of nested query coming up, which is called correlated queries. So guys, the queries that we have seen till now involving nesting were non-correlated queries. Okay, why non-correlated queries? Because the inner queries that we had were good enough to be run independently, right? Whereas in this case of correlated query, there is a kind of correlation involved. So we'll look into that. So what are correlated queries? So here goes the explanation. Whenever a condition in the where clause of nested query references some columns of a table declared in the outer query, then the 2 queries are said to be correlated. Okay. In the cases that we have seen till now, the outer query was dependent on the result coming from the inner query, right? But the inner query was kind of independent, and that's how we were doing it, right? We were trying to decode the inner query and then we were going outside. But in case of correlated queries, it is slightly difficult or different in the sense that the where clause of the nested means the inner query, would be referencing some column of the table in the outer query. Okay, and there's an issue with the efficiency in correlated query. Correlated queries are inefficient. Okay, we'll see that very soon. So the nested query is evaluated once for each tuple in the outer query. Okay, so what we should do, let's first look at a nested query which is correlated. Okay, so first of all, we'll try to see what is this query doing. Let's have some intuitive understanding of it, and then we will decode it and try to see if we are following anything. Select product number from product, okay, where what is this number 1 doing over here, and then there is a subquery select count star from purchase order line, we are calling that as POL, where, now this is interesting here, where P dot product number is equal to POL dot product number, right. First of all, what is this query trying to do? Intuition, right? Let's get the intuition first, and then we will dive deeper and we'll try to have even better understanding of the whole stuff. First of all, what kind of value we are expecting from the inner query? Scalar, or list? Non-scalar. Sorry? Look at the clause, okay? If you are using where with the comparison kind of thing, then that should be a scalar thing only. Count star will return in a value, right? Counting of how many records do we have here. Select count star, count how many columns, how many rows do we have in this query. Select count star from PO line. PO line is purchase order line, where we'll have the details of all the purchases that a supplier has made. Okay. First of all, let's look at this correlated part over here, right? And then we will worry about what the whole query is doing. Do we see any correlation? Pay attention over here. Okay, now just to motivate you people into thinking about the result, whether a query is correlated or not, that I'll ask. Right? That will be a simple question in the quiz. Given the nested query, does that query look like a correlated query or non-correlated, right? So is it correlated? If yes, then how? If not, then why not? So if you're not confident, then I'll take you to the previous slide and we'll see how is the correlated query defined. Whenever the condition in the where clause of a nested query, nested means the inner query, references some column of the table declared in the outer query, then the two queries are said to be correlated. Look at the where clause of the nested query or the inner query. Okay, how's that written? Where P dot product number. What is P? P is a table from the outer query, right? So in fact, yes, because this where condition is referring to a column from the outer table in the outer query, so this is correlated. All right, fine. So we solved that one puzzle, that yes, it is a correlated query. And now the question is, what are we doing here? This is correlated, okay? We cannot think of computing this inner query first and then putting that value here and then finding out the corresponding tuple. No. What will happen in this query execution? You will take a tuple, right? You will take a product number. Let's say you took the product number, what is it? Okay, probably this is related with, this is the result. So let's say we took the product number 0212. So from that table, product table, you took the product number. Let's assume that is 0212. Now that value would be used in this where clause, right? So what we will do here, we are kind of forming a join only here. Does it look like a join? Is this a join condition? It is in fact a join condition, right? But we should not call it a join because we are taking only one value at a time. So you take that product number, say it is 0212, and find the corresponding entries in the purchase order line, and you see how many tuples are returned for that specific product number 0212. And if this count is greater than 1, then we report that. Okay. So in plain English, what we are doing here, we are listing the product number of those products who have been listed more than once. Okay? Right, that's precisely what we are doing. That's the reason why it is 1. This value should be greater than 1, then only we will have that in the result. And look at the result, right? So this looks like a result. 0212, 0212 appeared 2 times. You are not looking at the whole record, right? So this is probably the, so this is coming from the product table, and this is the whole result, which would use purchase order line table as well. Okay? Okay, so let's keep moving. This is probably one of the toughest queries that we have, but let's see what are we trying to do. Good. Yeah. So here, when you get stuck with really complex query like this, what I would suggest is start from the where clause, right? Because where clause will, sorry, not where, from clause. Because from the we would have some idea about how many tables are involved, right? But again, you know what? This is nested correlated query. That will make our life a lot complex. But here you can start from here. For the outer query, in correlated queries, yes, you should start from the inner query. But inner query in itself is not sufficient because this is correlated with the outer query. Okay, so what are we interested in? We are interested in finding out supplier number, supplier name, right? So this R thing you can decode from the from clause. Supplier is being called R, supplier is called S1, product is called P. We are interested in supplier's number, supplier name, product number, product name, purchase price, and the purchase price is coming from the supplies table S1. Okay, and yeah, that's the relationship between supplies table has the relationship between the supplier and the product, and the price that we have is an attribute of the relationship. Okay, now fine. So this should not be a problem. The price, purchase price, is an attribute of the relationship, and the delivery period is also the attribute of the relationship, supplies. Okay, now excuse me, what are we doing in the where clause? In the where clause there are 1, 2 and 3 conditions. All right, so the first condition here is doing a join, the second condition is also doing a join. And what are we doing? We are doing implicit join here, which will make our life a lot simpler. All right. So R dot supplier number is equal to S1 dot supplier number, and S1 dot product number is equal to P dot product number. We join these 3 tables, right? And this is the most interesting part. All right. We are interested in finding out the supplier name, supplier number, supplier name, product number, product name, and purchase price and delivery period for that supplier and the product whose purchase price is less than, right, what? This thing over here, what is it? The average price for that product from all the supplies, right? So probably its English statement is a lot easier than the query that you're looking at. We are interested in printing the supplier name, supplier number, supplier name, product number, product name, and purchase price, delivery period for the tuple that is providing us the price less than the average price for that product. Got it? Average price for that product. That's the reason if you look at this inner query, what do we have in the inner query? Select average of the purchase price, average of the purchase price. Where do you have the purchase price? in the table S2 from supplies S2. So in fact, in the whole query, if you look at the table supplies has been referred twice. Once in the outer query, okay, given the name S1, and second time inside the inner query where we are calling it S2. All right. And what are we doing in the inner query? Well, we have the purchase price in supplies table only, but we don't want to find out the average of all the purchase prices. No, we want the average of the purchase price for this product that we are referring from the outer table. Okay. So if a product is, say, okay, I'm changing that to our domain. If the product is, say, Lenovo desktop, all right, so we want to find out the average price for all the Lenovo products which are being supplied by different suppliers. Okay, and I want to list that supplier name, supplier number, supplier name, Lenovo desktop, its product number, its name, purchase price, and delivery period for that record which is less than the average for that Lenovo product which is being supplied. Good. Really complex query, but yeah, challenging at the same time, right? So what I should do next, let's try to visualize it, right? So one good thing here is that the textbook helps us out in visualizing this difficult query. Fine, so this is the product. You are joining product and S1, right? So in the outer query, we join product, supplies as well as supplier. Project is being called P. Supplies in outer query is called S1 and supplier is called R, right? So using product number, you join this with supplies, and the supplier number you use to join it with the supplier. Good. And then what you do for its purchase price, right? The condition is on purchase price. This purchase price should be less than the average purchase price for all the products with the product number 0178. 0178. So this thing is from outer one, and this whole thing that you have is from the inner query. And in inner query we are computing the average, but this average is computed only for 0178. So what is happening here? It is correlated because from outer query, right, what you do, you take the product number. All right, and for that specific product number, you want to find out the average. Where did my pen go? The average values inside the inner query, right? And you are returning only that product whose purchase price here is less than the average price, right? So if you look at these values, other values are higher. So I'd assume that this record would be listed out. All right. So this query, the whole query thingy, along with this visualization will help you out in understanding this query. Okay. But what do we have here? It is a nested correlated query. One more query. Okay. Yeah. Now this is a query that will probably keep you people thinking. What are we doing here? We have an outer query and there's an inner query, and again this number 3 should not be confused with the position of the attribute in the table. What makes this query even more interesting is the use of same table name in the outer query as well as inner query, right? It should be less than 3. All right, so you know what? We have some hint over here. That is the result. Okay, so what are we doing in the inner query? Select count star from product, where P1 dot product number. This is P1, right? From here you will take one record at a time, one tuple at a time, and for that tuple you will compute the inner query. You will run the inner query. So let's say that the first one that you have here has the product number 0119. All right. So this is the product number. Look at these numbers: 0119, 0154, 0178. These are the product numbers. And inside the where clause, what we are doing, we are just checking whether inside the in a query where we are using P2 as the name for product, if that P2 dot product number is greater than P1 dot product number. All right. So these tuples that you are getting here would be based on some initial value of P1, say in the first record where this one where P1 has the product number as 0119, right. So from here we will list all those tuples for the products where their product number is greater than 0119, okay. And this thing, the count here is 41. For when you looked at the first product that has the product number 0119, for that this resulted in 41. Is 41 greater than 3? No. So that is not result and that is not returned. So first product number will not be listed. Let's look at the second product number 0154. Okay, so there are 40 other product numbers which are greater than 0154 and 40 is greater than 3, so that is not listed out. Whereas if you consider last 3 records over here, right, so 0900, if that was the product number you start from the outer query, then there are what, 2 more records with product number 0915 and 0977, right. So what will happen in this whole query, only the last 3 records they will be printed out. Why? Because those are the only products with their product order being the largest 3. Okay, so this interesting query is listing the product numbers which are largest 3, top 3 product numbers. Okay, yeah, it's interesting way, but yeah, that's